Right, in this video on the quiz review for 4.7 through 4.9, we can cruise from question 7 through question 11. Okay, so we'll start out with 7. It says to find the measure of angle AOB. So that's this angle right here in degrees and in radians. So the measure of this angle, you'll notice, shares the same endpoints as this inscribed angle right here. So 2 times that measure of angle D should be the measure of angle AOB. Okay, so let's see. One thing you may notice is that there's a triangle formed here. And something noteworthy is that since BO and OD are both the radius, they're both congruent. And since these two sides are congruent, the angles opposite of each other are congruent. So if that angle, let's call it just angle B, is 24 degrees, then we can say this angle here is 24 degrees as well. Now if this angle is 24 degrees, we know again that BA is 2 times that angle measure, since it's the intercepted arc of that inscribed angle, so we get 48 degrees. So we know that angle AOB is 48 degrees. So you can write right here, AOB is 48 degrees. How do we, though, find it in radians? Well, you guys know that we must multiply by pi over 180 to convert degrees into radians. We end up with 48 pi 180ths, which reduces down to 4/15. So we'll just leave that pi in there in the numerator. 4 pi 15ths. Okay, now it asks us to find the length of AB. Well, the length of AB, which is S, is the arc measure over 360 times 2 pi r. What is our radius in this case? Well, the question actually gives us that information. It says CO is 18 millimeters. And CO is a radius, right? It's from the center to the edge of the circle. So we can replace R here with, say, 18. 18. Okay, when we reduce this, we know 48 360ths. What's that? 4/30ths to 2/15. Okay, so 2/15ths times, and 18 times 2 is 36. So if we evaluate this, we get 72 pi 15ths, which if we divide the top and the bottom, the numerator and the denominator, by 3, we end up with, let's see, 72 divided by 3. That is 12 more than 60, which is 3 times 20, so 24. 24 pi fifths, and this is in millimeters. Okay, this is telling us if the measure of angle AOB, the measure of COD, is a 3:4 ratio, find the measure of angle BOC in degrees. So 48 degrees to blank equals 3:4. So we should have, we can set up something like this. In which case we can cross multiply. 48 times 4 is equal to 3x. I'll just evaluate this real quick. 48 times 4, 360 plus another 32, so 192, yep, 192. So we get 192 is equal to 3x. And if we divide both sides by 3, 192 divided by 3 is 64. So, in this case, BOC, I should keep it in red, angle, the measure of angle BOC equals 64. Okay, so BOC, kind of clear this stuff up. BOC in this case, BOC is 64 degrees. Okay. Now it says to find the area of the sector formed by BOC. So for finding the area, we do very much the same thing as when we find the arc length. The only difference is instead of using the circumference here, we use the area, which is pi r squared. So what's our radius? Well, we said previously that that's 18, because it's written in the question. What is 18 squared? Let's see. 324, okay. So we have 324 pi times 64 360ths. How am I going to reduce it? I can just plug it in, but if I were to do this in my head, I would first divide by 4, right, which would give me 16 90ths. I can divide that at least by, let's see, can I do 4, 80? No. Let's do 2, which gives me 8 45ths. And then this one I cannot divide any further. So we end up with 8 45ths times 324 pi. Okay. So that's not helping. 8 45ths times 324 pi. I'll start by doing 8 times 324. $2,592. See if it's divisible by 45, which it isn't. Does it reduce though? No, it can't. Maybe it can. 288 fifths. Really, at the end of the day, 288 fifths. At the end of the day, you could have plugged in first this into your calculator, and we showed you that trick, right? You enter it, gives you the decimal form, you hit math, and then enter, and it would have given you this, and then you could have multiplied 8 and 324, and have that over 45, and then type that into your calculator, and you would have got this, 288 pi fifths. So this isn't asking us to round to the nearest decimal, so honestly, if you have it just like this, is this in centimeters? Millimeters. And remember, this is area, so it's millimeters squared. Okay, 288 fifths millimeters squared. Let's see what this actually comes up to, 180.9. Okay, so 180.9. Let's look at number 11 now. Consider the circle shown. Find the measure of theta in radians and in degrees. Round to the nearest tenth. So it looks like, since we were given the radius length and we were given the arc length, that we'll first find it in radians, because theta is equal to S over R. It's the ratio of the arc length to the radius length. So in this case, we get 25 over 10, which means that it is 2.5 radians. Okay, 2.5 radians, or 5 halves. 5 half radians, whichever. I think it's easier actually to stick with the 5 halves when converting into degrees. So to convert into degrees, 5 half radians times pi over, no, we're converting to degrees, so it should be 180 over pi. So we can divide the top and bottom by 2. This will give us 5 times 90, which is 450, divided by pi, which gives us approximately 143.24 degrees. It says round to the nearest tenth. Okay, good. I rounded to the nearest tenth. So you should be getting 143.24 degrees.